Hello, algebra. Welcome to quadratic equations. This is probably the peak of our curriculum, is this unit. Couple main vocabulary words you really need to be familiar with. One, axis of symmetry. The axis of symmetry is a very important point in a quadratic because it is the line that divides a parabola perfectly in half. Hence the symmetry part, right? We're looking at that this half is symmetrical to this half. So that would be the axis of symmetry is the line that divides them in half. The vertex, we are looking at the peak point. It is the maximum and minimum spot. So you have the axis of symmetry is here, but the vertex is this point. It's an actual singular place. So you can have a high point, highest point, or a lowest point, depending on what type of parabola you're dealing with. Here we're dealing with a negative parabola or negative quadratic equation, so you have a maximum. But if your parabola was going up, again, you'd have your axis of symmetry in the middle. Your vertex is at the minimum, the lowest point, whereas here it's the highest point. Okay, so axis of symmetry, the pole, vertex, the point. You got to keep those two straight. So here it says you find the axis of symmetry, find the vertex, put the vertex in the middle row of the table, then fill in the table of values and using your calculator. Plot the points and connect them into a smooth parabola. Graph each quadratic equation using a table. Identify the axis of symmetry, vertex, domain, and range. So here we can find that the b term is 0. If you remember from last class, negative b over 2a is the formula for what? That's how to find that pole location, that vertex, that axis of symmetry, vertex, and the axis of symmetry. Because remember, the axis of symmetry is going to go through that point. Okay, so you have negative b over 2a. Well, here, the standard form for a quadratic equation is ax squared, meaning whatever the coefficient is in front of the x squared term, plus bx, whatever the coefficient is in front of the x term, the linear term, and then plus c, your constant. And so to use this formula, we really just need to concern ourselves with the b term and the a term. The problem is y equals x squared, this parent function, the original mother of all quadratic equations, doesn't have a b or c term. Well, there's 0. So what we would do is say negative 0, which doesn't exist, just 0, over 2 times a. Well, what is the a term in this case? What is the coefficient of the x squared term? Well, in this case, it's 1. Okay, but it could be 1,000, it won't matter because it's dividing into nothing. And so the vertex point, the original point, is 0. The x term is 0. And so what would the y location be? Well, you have to stick this equals 0. You have to stick this back into the equation to find the y. It's a function, right? So when I stick this back in, I say y equals 0 squared. So y equals 0. So my vertex, the southernmost point, the lowest, the minimum point, is 0, 0. Now, how did I know that it was a minimum and not a maximum? Because it's a positive equation. Remember, Mr. Gattani reviewed with you last time that when it's a negative parabola, when it's a negative quadratic equation, if it was y equals negative x squared, it would be facing downward. It would open downward. This is negative. This is positive. And so if it's facing downward, then it has a maximum, but if it's positive and it's facing upward, it's going to have a minimum. So the minimum is that vertex at 0, 0. Okay? And that would be also the point at which it's going through at x equals 0. So we're going to take the vertex and we're going to put it in the middle row as they asked. And now we can start putting the values above and below it. Now, Mrs. Evans, wouldn't I always want to start at 0, 0? Well, no, not exactly, because your minimum could be -6, +2, and be above the x-axis. Your maximum could be 52, 300. Like, we don't know, and it's so we want to make sure that whatever that vertex is, that point goes in the middle, and then we work from there. We work out to graph. Okay, so let's put in 0, 0. There's our happy minimum. So if our function is y equals x squared, and we know that x is going to equal 1, what is y? Well, 1 squared is 1, so y is 1. So when x is 1, y is 1. How about when x is 2? Well, x squared, or 2 squared, is 4. So when x is 2, y is 4. So 1, 2, 1, 2, 3, 4. How about -1? -1 squared, is that -1? Nope, negative times negative is +1. So when x is -1, y is +1. And the same thing, whoop, that should say -2. -2 squared is +4. So we go 1, 2, and then 1, 2, 3, 4. So there is the parabola y equals x squared. So let's take a look at our domain and range. Domain is all the x values that make this true. Okay, so how far to the left can we go? Well, we can go infinitely to the left. So it starts down there at -infinity. And if you recall, we use a parenthesis because -infinity is not a point, it's not a location, it's just a direction. So we're starting down at -infinity, and then we come along here and we pass the minimum and we keep going, and where do we stop? Well, we don't stop. It keeps going on forever to +infinity. All right, well, that takes care of the domain, but what about the range? So the range means all the y values that make this true. So what's the lowest point? Well, the lowest point is right here at the minimum, and that's at 0. And then it's all the y values, right? So the range goes from no lower than 0, but then goes up to +infinity. So it includes 0 and off to +infinity. All right, let's take a look at the second one here. Now we have a full trinomial for a quadratic equation. And where do we start? That's what usually trips my students up. Where do I start? Well, we want to start by finding the vertex and the axis of symmetry. So we can start with this -b over 2a. That's always a good starting point. So we have to be able to identify the a term, the b term, and the c term. The a term is 1, the b term is 2, and the c term is -1. So -b would be -2, where b is 2, times 2a, and a being 1. So what does this equal? What does this x term, what's the x value here then? -2 over 2, or also known as -1. So the vertex is x is equal to, or the axis of symmetry rather, is x is equal to -1. And to be able to find the vertex, we have to go back into the equation. The equation is y equals x squared plus 2x minus 1. Well, we now know that x at least for the spot of the highest point, or lowest point in this case, sorry, it's positive. The lowest point, x is going to be -1. So we can rewrite this using -1 every time we see an x. Now solve for the y. So we know that x will be -1, but what is the y value for that spot, that minimum? The minimum spot is -1 squared is 1, plus 2 times -1 is -2, minus 1. So this is like adding a negative. So we have -2 and -1 is -3, plus 1 is -2. Okay, so far, how did we get there? Well, we started with the vertex formula, finding -b over 2a. Once we found that point, that x value, we found, let's see, x is equal to, and we found what the x was equal to. So then we used that to sub that into the formula, substitute that in. Sorry, back into the equation. And found y equals what the y value was. Once you have your xy pair, you're going to use that to be the middle row of your table, and then find the values around it to graph it. Then you can decide your domain and range. Okay, so we now know that our vertex is -1, -2. Okay, and we're going to put that right here in the middle. So we could do -2, -3, and 0 and 1. We're using -1, -2, our vertex, to be the center, because that is the center. That's where the axis of symmetry is. Okay, so this is x equals -1 is the axis of symmetry. So the axis of symmetry is coming right down here. This is going to be the middle of our parabola. So that's why we put it in the middle of our table. So let's use 0. 0 is pretty quick and easy because it's 0. So if I go back to my equation, y equals x squared plus 2x minus 1, and I say y equals 0 squared, well, that's 0, plus 2 times 0, which is also 0, minus 1, when x is 0, y is -1. And then we use +1, so we'll stick it in, well, for x. 1 squared is 1, plus 2 times 1 is 2, so 1 plus 2 is 3, minus 1 is 2. Okay? Next, we stick in -2, so I'll do this off to the side. Again, I'm going to rewrite our equation. Y equals x squared plus 2x minus 1. And everywhere we see an x, we're going to put in -2 because that's the next spot in our table. So y equals -2 squared plus 2 times -2. I'm running out of room on my tablet here, and minus 1. I should have done that in yellow, but you know what I mean. Okay, so now what's the next part? The next part is y equals +4, because -2 squared is +4, plus 2 minus 2, or sorry, that should be multiplied, minus 1. So now y equals 4 minus 4 minus 1. Y equals -1. Okay. All we're doing is we're taking the x values that we just, where did I get the x values for the table? Well, first I used the vertex point, and then I just came up with the values above and below it. I just created them. I mean, I could have used 0.5 and negative 0.5, and I just used some easy values that were above and below the axis of symmetry, the left and the right of that point. So next, having a hard time here convincing my tablet what I want it to do. There we go. We need to put in our last point. We need to put in the point of -3. So y equals x squared plus 2x minus 1. Y equals -3 squared. And it's important that you put that square outside the parentheses. Okay, because -3 squared is not the same as -3 parentheses squared. And then plus 2 times -3 minus 1. The reason for that is because sometimes there may be like a negative out here, in which case that does not get squared. Like, you need to know your order of operations and how to write what the values are. Okay, so then we get y equals -3 times -3 is +9, and then 2 times -3 is -6, minus 1, y equals 9 minus 7, y is equal to 2. So we know that when x is equal to -3, y is equal to +2. All right, so now let's graph these points on the grid. All right, so we have our first point, our vertex. Our axis of symmetry is there in red dots, and then our vertex is there at -1, -2. Next, we're going to graph 0 and -1, and then we're going to graph 1 and +2. After that, we're going to come back to -2, -1, and then -3, +2. And we're going to carefully draw them here. Boom. So looking at domain and range, again, domain is all real numbers, meaning negative infinity to positive infinity. It's all the vertical lines from left to right. There are none that is not included. If I were to go to x is equal to -5,352,000, there would be a y value for that. If I were to go to x is equal to +3.26897, there would be a y value for that. So the domain is all real numbers. But what about the range? If I went to y is equal to +5, would there be an x value? Yes, there would. But what if I went to y is equal to -5? There would not. So my range goes no lower than y equals -2. So y is greater than or equal to -2. Or you could say -2, infinity. Oops, is another way to write that. Okay. All right, at this point, it's been close to 20 minutes of this. Hopefully you have enough material to get you started. Use your little checklist over here on the left. What you're going to do for number 3. Start with -b/2a. Find what that x value is equal to. Use that x value to substitute it back into your equation. Find the y. Use those x, y values to sub into the table and create a table of ordered pairs and find your parabola. All right, good luck.